Hello everyone, welcome to the Proteus simulation of uh, binary weighted digital to analog converters. So you can see the circuit in the Proteus software. It has four inputs A, B, C, and D. So the circuit is designed in such a way that is basically A is the LSB and D is the ASB. Since there are four inputs, we can actually have 2 to the 4 is equal to 16 possible combinations, and we can find the analog voltage in the output node of the op-amp UA741, that is node number 6. This is our output node. So we can find the output from this from the voltage level of this node. And now we have also used four switch SPDT switches to toggle between the logic high level and logic low level. So let's see what happens when you run the simulation. So now basically our all switches are connected to ground. So that means basically we have a digital input of a 0000, and our output is, you can see it is approximately 0, close to 0. Now let us see what happens when you toggle one input. That means LSB of input 1. You can see we're getting close to 0.5 volt. That means basically for a digital input of a 0001, we are getting an output of a 0.5. When what happens when we get digital 2, for a binary 2, that means we have our P input will be 1 and A will be 0, and you can see the output is 1. That is when input is basically 2, output is 1.199 volt, or approximately 1 volt. When input is logic 3, that means 0011, so 0, it is 0011. We can see the output is close to 1.5 volt. In a similar way, you can find the voltage level of all 16 possible combinations of input, that is from 0001 to 1111. You can see the output is increasing at a rate of 0.5 volts. So we can approximately, so we can say the step size of this digital to analog converter is 0.5 volt. We can actually control the step size using by changing the value of this RF resistor, which is called the feedback resistor. You can know about this from the theory section of the lab. So we can, if we want to, for example, if we want a higher voltage of step size, we can actually calculate it and finally find out the necessary resistance values to achieve that step size. Also, if we also can increase the possible input levels, that means, for example, I want to add 5 input, that means 5 bit of digital signal. That for that we need to add another inputs voltage source and other resistor, and which will be a half of this, means half of 1.25. We have to go in the similar way for any other more than 4 inputs.